Hello, algebra students. Mr. Lawrence here, and today we're going to be able to say I can factor by grouping. Yeah, we're on our second type of the big F word, and actually, factoring by grouping is just GCFing. In fact, it's just GCFing. Let me find a good card like Poiple. It's just GCFing 3 times. That's all we're going to do. If you're good at GCF, which is pretty easy to be good at, we're going to just GCF 3 times, and I'll show you how it works. But first, before we do that, let's just review really quick GCFing. Let's look at these two quantities, and I'm going to two separate problems. So we'll look at review problem number 1 here first. I'm going to find the GCF of 24 and 30. Well, I think that's 6, right? So I'm going to divide by 6. Then remember, my GCF goes out front, right? It doesn't disappear from the problem. Okay, and then my GCF of x to the fourth and x cubed, well, that's going to be the smaller of the exponents. It's going to be an x cubed. X cubed is common to both terms. So what's left here? Well, 24 divided by 6 is 4. X to the fourth divided by x cubed is x. 30 divided by 6 is 5. X cubed divided by x cubed, they cancel. There we go. We just GCF'd. Okay, do this one really quick. The GCF of 27 and 9 is going to be 9. The GCF of x to the fifth and x squared, the smaller the exponents. Again, don't try to take it all at once. Try to do it coefficients, then the x's, then the y's, then the q's, then the watermelons, then the fire trucks, then the porcupines, but do them in steps. If you do them in steps, they're very simple. Okay, I need the GCF of the r's. Well, I have an r squared and an r cubed, so it's going to be an r squared, the smaller of the exponents. So my GCF goes out front, doesn't disappear, and 27 divided by 9 is 3. X to the fifth divided by x squared is x cubed, and the r squares cancel. Over here, 9 divided by 9 is 1. X squared divided by x squared is also 1, but I'm not going to write times 1 down. It might look like an 11. And then r cubed divided by r squared is plain old r. Or, if you're actually literate, r to the first. There we go. Pretty easy stuff. So come on down here and let's learn how to factor by grouping. And remember, I promise you, we're just going to GCF 3 times. Now, you're going to know it's time to group when you see 4 terms. Did you hear that? When you see 4 terms, Jamaica, were you listening? 4 terms. I said when there's 4 terms, we group. When, what's that, Jake? What's that? Oh, yes, very good, Jake. When there are, how many? How many, Dylan? 4 terms. 4 terms. Okay, so what I'm going to do is I'm going to make 2 pairs of groups, 2 sets of groups. The only rule when I do this is I have to make sure there's a GCF in each pair. If there's not a GCF in each pair, I can rewrite the problem. But if there's a GCF in each pair, I'm good to go. And this is almost like magic. It's so simple. It's very cool. So I'm going to group these 2 together. And I'm just going to look, is there a GCF between there? Yeah, I think there is. I may not know what it is, but it sure looks like it. Now this is very, very important. Very, very important. Jared Martz, are you listening? This is very, very important. When I go to group the second pair, I'm always going to grab the sign in front of the number and then stick a plus between the quantities. Always grab the sign. It doesn't matter so much when it's a positive, but when there's a negative there, it makes a tremendous difference. So always grab the sign into the group. Okay, now all I'm going to do is find my shade. I'm going to GCF this first group, which I know is real simple for you. GCF between 6 and 18 is going to be 6. GCF between x squared and x, put a little 1 there if I'm Ashley Leonard, is x. So my GCF is 6x of the first group. So I'm going to get 6x, and then 6x squared, or 6 divided by 6 is 1, and then x squared divided by x is x, plus 18 divided by 6 is 3, x to the first divided by x to the first, they cancel out. Okay? Now, I'm going to go and GCF the second group. By the way, I just GCF'd one time, right? Remember I said I was going to GCF 3 times? I just GCF'd one time. I GCF 3 times, I'm going to be done with the problem. So let's look at this. Okay? I'm going to find the GCF of 2x and 6. Well, the GCF of 2 and 6 is 2. And there's an x to the first here, but there is no x over here, so that's my total GCF, just a plain old 2. So what's left inside? Well, 2 divided by 2 is 1, x to the first, and then 6 divided by 2 is 3. Okay, now look at this. Oops, wrong button. There we go. Okay, if you look, I GCF'd once over here with the 6x, and then I GCF'd twice over here. Now remember the GCF, the F stands for factor, right? And factors are the parts of a multiplication problem. We should know this. For example, 3 times 4 equals 12. These are the factors, right? So the factors are numbers that are being multiplied together. Well, listen to this multiplication problem. I've got 6x times the quantity of 1x plus 3. Did you hear that? And then over here, I have 2 times the quantity of 1x plus 3. Did you hear me say the same factor twice? Listen again. 6x times the quantity of 1x plus 3 plus 2 times the quantity of 1x plus 3. Ooh, I said the 1x plus 3 twice, didn't I? Guess what? It's a common factor. And here's where the cool stuff comes in. Since 1x plus 3 is common to both sets, I can pull it out front. I can GCF. I can divide this by 1x plus 3 and divide that by 1x plus 3 because it's common to both terms. And then I GCF it. I pull it out. Remember, my GCF never disappears. My factors never disappear. Okay? So what's left here? These will cancel, leaving me a 6x. These will cancel, leaving me a 2. And there you go. There's your third GCF right there. You just GCF'd 1 time, 2 times, 3 times. All right, let's try this again. Okay, remember to group. I need to pair up, make 2 pairs. There's 4 terms here. I'm going to make a group of 2 and another group of 2. Got to make sure there's GCF in both groups, and I like my GCF there. The second one does have a GCF. I'm going to grab that negative, and then I'm going to put a plus in between. All right, so now I'm going to GCF 1 time. I'm going to look for the GCF of 50 and 40, which I believe is 10, and the GCF of x squared and x is going to be x. So I pull out the GCF, and then I'm left with 5x. Pulling out the GCF from the second term, I'm going to get 4, right? I come over here. Now, some of you are going to think the GCF is 3, and I don't totally disagree with you, but you notice how they're both negative. I'm going to suggest pulling out a negative 3. When they're both negative, pull the negative out with the GCF. So there's my GCF, negative 3. Negative 15 divided by negative 3 is a positive 5. There's an x there. Negative 12 divided by negative 3 is a positive 4. And look at this. I have 10x times the quantity of 5x plus 4 minus 3 times the quantity of 5x plus 4. I GCF'd once, the 10x. I GCF'd twice with the negative 3. Now I'm going to GCF the 5x plus 4. I divide by 5x plus 4. I bring it out front what I divided by. What's left in this first part? Well, these will cancel, leaving me a 10x. These will cancel, giving me a negative 3. And there you go. Ooh, I hope you're starting to like this because this is pretty easy stuff. Okay. Oh, no, danger, Will Robinson. Danger, danger. Defense shields up. Forgot to get rid of an answer. Sorry about that. Now, I'm looking at GCF number 3. The only problem is I don't see a GCF between the first two terms. Well, you know what I'm going to do? I'm going to rewrite it. I'm going to rewrite it as 28x squared. And you know what? I see a GCF here with a negative 4x. So we're going to put that in. My 28 is bigger than my 4. I'm going to group those together. So I'm going to write 35 next. 35x, and then minus 5. I'm just doing this to make it easier on myself. Notice how I have the larger coefficient in front, and then there's a minus in the middle. Minus in the middle. I could have written it negative 5 plus 35x, but it creates an extra step or two later. All right, so I've grouped. Looking for my GCF of 28x squared and 4x. Well, the GCF of the coefficients is going to be 4. GCF of the variables is going to be x. So my GCF comes out front. 28 divided by 4 is 7. X squared divided by x is x. 4x divided by 4x is 1. Be careful there. Make sure you get that 1. Don't lose that 1. Hear that, Kyle Smith? That 1 is very important. Now I go looking for the GCF of the 35x and the 5. Well, the GCF of 35 and 5 is 5. And there's only an x on one term, so it's not common. So my only GCF is 5, so I'd be at a plus 5. 35 divided by 5 is 7. There's an x there. 5 divided by 5 is 1. And look at this. So I've GCF'd 1 time, 2 times, and now I have 4x times 7x minus 1, and 5 times 7x minus 1 as a quantity. My GCF is 7x minus 1. Oops, sorry, got ahead of myself there. So I'm going to divide this side by 7x minus 1, and this term by 7x minus 1, which means that's my GCF. Bring it out front, and when I divide by that on the first term, those cancel, leaving a 4x. Over here, those cancel, leaving a positive 5. And there you go. There's my third GCF, and I'm done. I know this video is running a little bit long, but that's okay. I want to give you lots of examples. Oh no, I did it again. Good. Okay. Let me see if I give myself enough room here. Whoa, what was that? Sorry, ladies and gentlemen, forgot I was still in write mode. Control G. I love my smartboard and my technology is so awesome. All right, here we go. Gonna look to group. Gonna look to group. And I don't like the order that they're in. So I think I am going to put, let's see here. There's a lot going on in this one. I'm going to put the 10x squared with the positive 8. For some reason that all ungrouped. I don't know why. And then the 15xy. Yikes. Going to put that here. All I'm doing is rewriting so that my GCFs will match. Okay, I like this a lot better. And I'm just going to move it up a hint so I have a little bit of room to work. Now I like it. I'm thinking ahead. I'm thinking about my GCFs. So I got to group these two. I know there's a GCF there. Gonna group these two, always sticking that plus in the middle. All right, so my GCF of 10 and 8, I believe is going to be 2. My GCF of x squared and x to the first is going to be x. And r is not common to both, so my GCF for the first two, for my first group, is 2x. 10 divided by 2 is 5. X squared divided by x is x. 8 divided by 2 is 4. The x's cancel. There is an r there. So I have 2x times the quantity of 5x plus 4. Now the GCF over here looks like it's going to be 3. It looks like y is common to both, but the x isn't common and the r isn't common. So I'm going to pull out a 3y, and I'm going to be left with 15 divided by 3 is 5. The y's cancel. There's an x. Over here, those cancel. The y's cancel. I'm left with an r. Uh-oh, we're stuck. Either Mr. Lawrence made a mistake, which I think he did, or this problem's not done. I'm going to double check my math, and this one would be prime because it can't be factored any further. You see how there's a 5x plus 4r here, and there's a 5x plus r. They don't match, so they're not a common factor. Okay, it's actually a mistake on my part. I apologize for that, but can't be factored, so it's prime. Okay, let's take a look at the last one. It's okay because this video is running long anyway. I'm going to go ahead and rewrite it. I'm going to put my m terms together. I think I'm going to go with 12 minus 8v plus 3m minus 2mv. And I'm going to go looking for the GCF. Okay, so gonna group, stick a plus in there. Now I'm gun shy. I feel like this one's gonna mess up too. All right, GCF of 12 and 8 I think is 4. That's gonna be it totally. So I'm gonna pull a 4 out, and I'm gonna be left with a 3 minus 2v. Okay, gonna look for the GCF of the second group. Looks like it's gonna be m. M is gonna be the common factor. So I'm gonna pull out an m. And I'm going to get 3 minus 2v. And there we go. I GCF'd once, I GCF'd twice. And look at this. This quantity of 3 minus 2v shows up in both terms. I'm going to GCF a third time, pulling out the quantity of 3 minus 2v. And that will leave me a 4 and plus an m. All right, we're going to get lots of practice with this in class tomorrow. A little bit of a long video, but that's okay. You got the weekend. I would recommend watching it more than once. All right, Mr. Lawrence signing off. Good night, everybody.